Modeling of mineral deposits is a process that accompanies almost the entire history of geological exploration. Before the advent of computers, geologists built geologic cross-sections, described wireframe and block models. With the advent and development of powerful computers, the ability to create three-dimensional with a sufficiently high degree of detail became possible. Modeling assumes the use of abstraction and idealization procedures. It is especially important in the case when complex modeling systems are the subject of modeling, whose behavior depends on a large number of interrelated factors of different nature. A feature of modeling, the mineral deposit structure and the properties of mineral raw materials in the subsoil, is that not true geological structures and properties of minerals are modeled, but representations about them obtained with a given detail of geological exploration. The appearance of three-dimensional geological modeling was possible due to the following main factors: development of mathematical principles and algorithms of three-dimensional modeling, development of related areas of geological and geophysical knowledge, the emergence of sufficiently powerful computers and workstations that allow performing complex mathematical calculations with sufficient speed and visualizations of the results, development of commercial programs providing a cycle of building three-dimensional models, accumulation of extensive experience in two-dimensional geological modeling, resource estimation, and oil and gas field geology. The main tasks solved in the process of three-dimensional modeling of deposits are data processing of any kinds of sampling, drafting of geological maps and cross-sections, creation of three-dimensional wireframe and block models of ore bodies, coal beds, non-metallic raw materials, considering digital models of functioning open-pit mines and faulting, the study of special characteristics of useful components on the basis of modern geostatistical methods, resource calculation with different limiting conditions, and operational replenishment of information and correction of the model in real-time mode based on data obtained during monitoring at the development stages of the mineral deposit. The following types of works are carried out during 3D modeling of a deposit. First, wireframe modeling of the deposit geological structure. Second, if mining operations were carried out at the deposit, then additional modeling of open-pit mines and underground mines is carried out. On the basis of geostatistical analysis, the distribution of useful components in ores is determined. Block modeling is performed with the creation of a model of ore quality and additional block model of geomechanical properties and hard geological parameters. Fourth, the results of optimization and planning of mining operations are the basis for creating an optimization model for mining planning. In modern mining and geological information systems, as a rule, two types of three-dimensional modeling are provided: wireframe and block modeling. These two methods differ significantly from each other, but the first, in most existing algorithms, is an integral part of the second. The wireframe model delineates the ore body in three-dimensional space by a set of triangles. Inside the body is ore, outside is a waste rock. The block model consists of a set of bricks, generally of different size, with various values of a useful component content. In more detail, consider the features of block modeling. The modeling is based on the division of the field space into elementary blocks or cells, into which the values of the object properties, in particular the content of a useful component, are interpolated from the initial sampling data, taking into account the weight coefficients. One of its variety is geostatistical modeling, based on the mathematical apparatus of a random functions theory. This type of modeling and resource calculation has been widely spread abroad and, to a certain extent, in our country. The introduction of block modeling in the practice of the mining industry is due to the objective reasons, including the development of computer technology. The present software packages are oriented to the solving of a wide range of tasks in the area of field development. Largely, they are aimed at the automated design of mining operations, drawing up a calendar schedule for the deposit development, managing the quality of mined ore and the ore control process implementation, etc. Resource calculation is one of the basis operations in this complex. Broadly, we should talk about the use of information technology in the field of mining. The simplest type of three-dimensional model of a deposit is a rectangular spatial lattice, where each cell has the same orientation and contains a single characteristics for each variable. This type is used by most mining and geological information systems. The size of the cell should be small enough to take into account all the nuances of the shape and internal structure of the mineral deposit. A successfully constructed block model shows the distribution of a useful component in the ore body better than the wireframe model. The total ore reserves, in case of the block model using, are composed of the reserves of all the constituent bricks. Accordingly, the resource calculation for this model is more accurate. In Canada, Australia, the United States, and many other countries, during the exploration of mineral deposits and resource estimation, the use of the principles of a block model is prerequisite. Further development of automated and robotic technologies is impossible without the implementation of qualitative geological modeling. Today, experts in the field of mining are faced with the task of moving from static geological models to dynamic ones, which will allow managing the quality of mined minerals at a higher level. In this case, mining geological information systems should become software that will allow uniting all the processes of exploration and development of mineral deposits in one information field. Today in Russia, there are examples of controlling by mining and geological systems the drilling rigs and the creation of blast holes for explosive breakage of rock mass. In the world, the examples of the implementation of unmanned control of dump trucks, excavators, and other types of mining equipment exist. To date, a significant shortage of a fundamental knowledge in many areas of science when creating models is felt. Especially, it observed during working with complex natural objects and processes, for example, rock massives, a layer of groundwater, the formation of mineral deposits, etc. Mining geological systems are extremely complex. A large number of factors that cannot be fully taken into account influences their state. Analytical methods developed in the 20th century for modeling the geological environment, including the process of subsoil development, allow calculating the change in the state of systems under the influence of a relatively small set of parameters with high accuracy. In most cases, it is not more than 5% of the total number of factors that affect the parameters and state of the system. The rest part is taken in the form of constants or not taken into account by the model. Naturally, the factors that are discarded in modeling do not have a decisive impact on the result, but in modeling conditions, when it is necessary to achieve high accuracy or forecast and assess the state of objects in some cases, the use of such models may be unacceptable. The current situation calls for the development of new algorithms for information processing, which rely on non-analytic methods. In the last couple of decades, methods based on the principles of neural networks, automata theory, etc., have become widely used. However, creation of learning systems requires data sets, which will be training sets. In the practice of geology and mining, such sets of data are difficult to form. First, geological objects are very diverse and distinguished by the absence of analogs. Secondly, the total number of objects being developed is relatively small, and large data sets is closed for a wide range in order to ensure the information security of enterprises.